The electrophilic aromatic substitution mechanism is all about finding a good electrophile. So what we learned is that we can't use just bromine to add to the double bonds in a benzene ring because it's not a good enough electrophile. Not good enough. So we found we could add Lewis acid catalyst that would make a good electrophile out of bromine. So here's our FeBr3. And now the way this reaction works is the pi electrons that are part of the pi system in the benzene ring will add to a good electrophile. So you're wondering why it's not going over to the plus charge. Well, it's a formal plus charge. This is easier to reach, and then we'll push the electrons over there, and that takes care of the charge issues. But let's look at what results. So we'll add that bromine on, and we took electrons away from this position. So the H is still there, but so now is a plus charge. And the others still have their protons. I'm just going to leave them off for clarity. Now, with a plus charge on the ring, we can move electrons around and write new resonance forms. So this would leave a plus charge at this position, and our bromine electrophile is in place. And then we can move electrons again and have the plus charge be located up here, still next door to where the electrophile added, and there's our double bonds. So this resonance picture shows, if I can just sort of write a hybrid structure, I still have my H and my Br. In fact, every position has an H. But what we show is that if I put in parentheses a plus charge, that's one place it can be. I'm just going to put this little, actually that's not quite right either, because those electrons are located around these carbons, and so not here. As you can see, it's never over here. The plus charge is located sort of throughout the other carbons, but it's formally located in the 3 positions where I'm putting a parentheses around a plus charge. Okay, that just is the hybrid structure for the 3 parts that we see up here, the 3 resonance forms. And so we call this set of resonance forms, illustrated by this one, we'll call this the sigma complex. Okay, just where are the plus charge located in a formal sense. Now the next part of the mechanism will be to finish that. So what we have left is that there's an FeBr4 with a negative charge associated with it because the plus charge is located on the benzene ring. So what it will do is come along and I'm going to grab a proton, and that will allow the electrons to return the ring to aromaticity. So I'll have this and my bromine now, and then H's on the remaining carbons as they were before. And so what you can see is we substituted one H for a bromine. So if we went back here, we could choose an H. It doesn't matter, of course. This compound is symmetrical, and any position could be equally added to. We'll find in some other examples when we already have a substituent present, then there is a preference, and that will be separate.